Hello everyone, I am Shubham from IIT Bhubaneswar and in today's lecture I will discuss about the Hinsberg test. For which purpose we are doing this test? That is for distinguishing between 1 degree, 2 degree and 3 degree amine. Okay, let's see how it goes. That is, if there is a primary amine, then when we use benzene sulfonyl chloride, there is a PPT, that is precipitate formation, which is soluble in sodium hydroxide occur. Okay, and if there is secondary amine, again with this reagent, Hinsberg reagent, a precipitate formation occur, but not soluble in sodium hydroxide. Okay, and if there is tertiary amine and we use Hinsberg reagent, then there is no precipitate formation. Let's see its mechanism. That is, when we have primary amine, okay, when we have primary amine with benzene sulfonyl chloride, that is okay, benzene sulfonyl chloride, and it here is lone pair present on nitrogen which attack on the sulfur, and we got a species okay. Now there is a breaking out double bond present between sulfur and oxygen, and again to gain stability, the electron present on oxygen again donate to the sulfur, and the cleavage of sulfur chlorine bond occur, and we got the species here, that is a positive charge on nitrogen. And again, as we know now, the chlorine anion is present in the solution which attack on this hydrogen and give us hydrogen chloride plus okay. And now there is a precipitate formation. Now let's see it is soluble in water or not, soluble in sodium hydroxide or not. Now here is hydrogen present with on this nitrogen. That's why when we use sodium hydroxide, then this OH negative take this hydrogen and give us water plus a species that is soluble in sodium hydroxide. Okay, so by seeing this precipitate formation and soluble in sodium hydroxide, we can say there is a primary amine present in our solution. Okay, now let's see the mechanism of secondary amine. That is again nitrogen, hydrogen, here lone pair present, and when it react with benzene sulfonyl chloride, attack on sulfur and break the sulfur oxygen double bond, and we got here a positive charge on nitrogen. Again, to gain stability, it will donate the electron to the sulfur and cleavage of sulfur chlorine bond occur, and we got again a positive charge on nitrogen. And as we know here, the chlorine anion is present in the solution, so it again take this hydrogen and give us hydrogen chloride. Okay, and then we get a neutral species. Now if we use sodium hydroxide here, there will be no hydrogen that will give us water, so that means there will be no further reaction, that is precipitate form, but not soluble in sodium hydroxide. Okay, precipitate form but not soluble in sodium hydroxide. Now let's see the tertiary amine mechanism. If we use tertiary amine, that means there will be no hydrogen, and when it react with benzene sulfonine chloride, it can attack on the sulfur, but there will be no product. Why? Because again when we use this, a chlorine anion will be produced, okay, but that chlorine anion can't take any hydrogen because there is no hydrogen on this nitrogen, because it is tertiary amine. So there will be no further reaction, or we can say no precipitate formation here. When here is chlorine, but now there is no hydrogen, so no precipitate formation, no PPT. Okay, thank you.